Alright, so this video I'm going to do my third example on solving first order linear differential equations. Alright, so we'll run through this like we did in the first two videos. So here's a linear first order differential equation, and P and F are continuous functions of x, and this is said to be in standard form. Okay, notice we have the dy dx has a coefficient of 1. Okay, alright, so to solve our equation, we first need to put it in standard form. Okay, sometimes it may not be in standard form. There may be something in front of the y prime here, or the dy dx, and we would have to divide through by that. Alright, and then we need to identify p of x and find the integrating factor. And this is our integrating factor, e raised to the integral p of x dx. Then, once we find our integrating factor, we need to multiply the equation from step 1, which is our differential equation in standard form. We need to multiply that by the integrating factor. And then once we do that, the left-hand side here is the derivative of the product of the integrating factor and the dependent variable y. Okay, and I'll show you all this how it works. And then we just integrate both sides of the equation found in step 4. Okay, alright, so let's take a look at this third example. Alright, so here we have an initial value problem to solve. See, they give us a condition y of -2 is equal to 0. Alright, so when we look at this, alright, notice that this equation here is not linear in y. You see how we have this y squared here? It's not linear in y. So what do? Well, we look at it and we notice it's not separable. Okay, so we can't use the separation of variables or separable equations. It's not homogeneous, and it's not exact. Alright, so looking at this, if we take the reciprocal of both sides, so that would give me dx dy equals x plus y squared, and then I move the x over, that's dx dy minus x equals y squared. So this differential equation here is linear in the variable x. So I'm going to do just like I did in my other two examples if you watched those, except I'm going to do it with the x here, and this is going to be dx dy. So instead of dx dy, or I have dx dy, so instead of having y prime like you normally do, this will be x prime minus x equals y squared. So you can see I have it in this form, except instead of y prime, I have x, instead of y prime, I have x prime. And instead of the y here, I have an x. And then this function is in terms of y. See, I had the y squared over there. So we're going to do everything the same way. It's just going to kind of be backwards. Alright, So let's go ahead and get the integrating factor. Okay, and if we look back over here, our integrating factor is e raised to the integral of px dx. So that's e raised to the integral of, and in this case it's going to be the number or whatever we have in front of x. Okay, and since we have the x prime and the x, instead of integrating with respect to dx, we'll be integrating with respect to dy. Alright, so my integrating factor, I have e to the integral, and then what's in front of x? Well, that's -1 dy. And so this is going to give me e to the -y is my integrating factor. Alright, now I found my integrating factor. So what does it say to do? It says multiply the equation obtained in step 1. So we multiply that standard form of the equation by the integrating factor. Alright. Alright, so let's get our equation. We have it right here. Here's our standard form. And so that's going to be x prime minus x equals y squared, and I'm multiplying that by the integrating factor. So if I distribute this, that's going to give me e to the -y times x prime minus e to the -y times x equals y squared e to the -y. Alright. Now, let's go back and look at what we have here. So, we've done this step. Okay. So, it says the left side of the equation, which is this left side here, okay, is the derivative of the product of the integrating factor and the dependent variable y. Well, in our problem, it's going to be the derivative of the product of the integrating factor and the variable x. Okay, so let's go back to our example. So this is going to be the d, and it's dy, not dx, because of what we did up here. Okay, and that's the product of the integrating factor and x. So there's my integrating factor, there's x, and that equals the y squared e to the -y. Alright, and you can see that if we look at this and we take the derivative of this, so let's just take the derivative of this, that would be the product rule. So it's the derivative of this term, which is x prime times the second term, e to the -x, plus the derivative of the second term, which that's going to be e to the -y times the derivative of the exponent, so times -1 times the first function. And you can see that we get x prime e to the -y minus e to the -y times x. And you can see this, we took the derivative of this, we just did this right here, and we got this left hand side. Okay, that's where that comes from. Alright, so let me erase this. And now all we do is we integrate both sides. Now remember, we're integrating with respect to y. Okay, alright, so over here I get x e to the -y equals. Now, for this side, I'm going to have to use, change colors. I'm going to have to use integration by parts. Okay, and I'm not going to go through that in this problem, and actually you're going to have to do it twice. Okay, so I'm not going to go through this. I have some videos where I do integration by parts. You can check those out if you need to refresh your memory on it. Okay, but doing integration by parts twice, I end up getting negative y squared e to the negative y minus 2y e to the negative y minus 2e to the negative y plus c. Okay, so now let's just come over here and solve this thing for x. So I'm going to divide everything by e to the negative y. And that will give me x equals negative y squared minus 2y minus 2 plus, and then I'm going to move this up into the numerator, c e to the negative y. Alright, so if you remember, we had a condition on this. Y of negative 2 is equal to 0. Alright, so let's come down here. I've got y of negative 2 equals 0. Alright, so here I have x is negative 2 and y is 0. Alright, so let's plug that in. So I get negative 2 equals, and then plug the 0 in. Well, that's just going to give me 0 minus, and that's going to be 0 minus 2 plus c times e, and then I plug 0 into here. So that's going to give me negative 2 equals negative 2 plus, and then of course e to the 0 is 1, so that's just going to leave me with c. And so I get c is equal to 0. Okay, so plugging the 0 into here, see if I replace this with 0, that's just going to go to 0. So my final solution is x equals negative y squared minus 2y minus 2, because this term here went to 0. And this would be my solution. Alright, so I hope this video helped. If you like it, you can check out my other videos, and if this is the first video that you watched for my first order linear differential equations, you may want to go back and watch the first two where everything's in terms of y. Okay, where we have y prime, it's linear in terms of y. With the variable y, it's linear. And that might help some. Alright, so check out my other videos. Thanks.